In this video, we are going to talk about coagulation, which is one of the properties of colloids. Now, what is coagulation? Coagulation simply means the process of converting a colloidal solution into a precipitate. Now, the stability of the colloidal solution is because of the charge which is present on the colloidal particles. Some colloidal particles are positively charged, some are negatively charged. But all the colloidal particles in a particular colloidal solution carry similar charge, and due to this charge, same charge present in all the colloidal particles, there is a repulsive force between them which prevents them from aggregating or coming together and getting converted into a precipitate. So if somehow we remove the charge of the colloidal particles, then they will start aggregating, that is coming nearer to each other, and will get converted into a precipitate, that is they will coagulate. And once they aggregate, that is get converted into larger size particles, they will settle down under the force of gravity. So we can say that the process of settling down of colloidal particles is called coagulation or flocculation of the sol. Now this coagulation of lyophobic sols can be carried out in several ways. The first method is electrophoresis. Now in electrophoresis, an electric potential is applied across a colloidal solution, and under this applied electric potential, the colloidal particles, which are charged particles, they start moving towards oppositely charged electrodes. Once they reach the oppositely charged electrode, they lose their charge, that is they get discharged and start aggregating, getting converted into a precipitate, that is they get coagulated. The second method could be by mixing two oppositely charged colloidal solutions. So if we mix a negatively charged colloidal solution with a positively charged colloidal solution in equal proportions, then the charges present on these colloidal particles will neutralize each other and hence result into mutual coagulation of the colloidal particles. The third method could be by boiling. So when we boil a colloidal solution, the adsorbed layer of the ions which are adsorbed on the surface of the colloidal particles, that gets disturbed due to increased collisions between the molecules of the disperse phase and the dispersion medium. This will reduce the amount of charge present on the colloidal particles and ultimately will lead to conversion of the colloid into a precipitate, that is settling down of the colloidal particle will result. The fourth method could be persistent dialysis. If we carry on dialysis for a longer period of time, then that will result into removal of even traces of the electrolyte which are present in the colloidal solution. And as we know that small amount of electrolyte are required for the stability of the sol. So if we are removing even traces of the electrolyte ions, then the colloidal particles will lose the charge which is present on the particles, and again this will result in the molecules or the particles associating with each other, coming nearer to each other, aggregating and thus converting into a precipitate, that is getting coagulated. The next method could be by addition of electrolytes. Now electrolytes produce both positive as well as negative ions in the solution. So when an electrolyte is added in excess to a colloidal solution, then the ions of the electrolyte, which are opposite in charge with respect to the charge present on the colloidal particles, will start neutralizing the charge of the colloidal particles. And once the charge on the colloidal particles is neutralized, then the repulsive forces which were acting previously between these colloidal particles will no more be functional, and hence the particles will start aggregating and changing into larger size particles, and thus that will lead to coagulation of the colloidal sol. So if the colloidal particles are positively charged, then a negative ion will cause the coagulation, whereas If the colloidal particles are negatively charged, then a positive ion will cause the coagulation. Now Hardy and Schul have put forward a rule known as Hardy-Schul's rule that explains or that governs the coagulating power of the electrolyte ions, and it says that the greater is the valency or the charge of the coagulating ion, that is the electrolyte ion added, the greater will be its power of coagulation. So for example, if we have a negatively charged colloidal sol and we want to coagulate it by adding an electrolyte, and suppose we add 3 different electrolytes and compare their coagulating power, and the electrolytes are producing aluminium 3 plus ions, barium 2 plus ions, and sodium unipositive ions, then the coagulating power of these ions can be arranged in the following order. That is, aluminium ions will have a greater coagulating power as compared to barium ions, and barium ions will have a greater coagulating power as compared to sodium ion. This is as per the Hardy-Schul's rule. Greater is the valency or the charge of the coagulating ion, greater will be its coagulating power. So since aluminium ions are carrying 3 positive charge, which is more than the barium ion which carry 2 positive charges, which is again greater than sodium ion carrying a single positive charge, so their coagulating power also decreases in that same order. Similarly, if you are having a positively charged colloidal solution, then we will need negatively charged ions for coagulating this sol. The coagulating power of some of the negatively charged ions can be given in the following order. First one is the ferrocyanide ion, second one is phosphate ion, then sulfate, and then chloride ion. As you can see very well, the ferrocyanide ion carries 4 negative charges, which is greater than the phosphate ion which carries 3 negative charge, which is again greater than sulfate ion which carry 2 negative charges, and further which is greater than chloride ions which carry a single negative charge. Now the coagulating power of these coagulating ions can be expressed in terms of their coagulation or flocculation or precipitation value. Now what is meant by the term coagulation value of a coagulating ion? The minimum amount of an electrolyte which is required in millimoles to cause complete coagulation of 1 liter of a colloidal solution is called the coagulation value or precipitation value of the coagulating ion or of the electrolyte. So smaller is the quantity needed, the higher will be the coagulating power of an ion. Means the smaller is the coagulation value of an electrolyte ion, the higher will be the coagulating power of that ion. As compared to lyophobic sols, lyophilic sols are more stable, and the stability of lyophilic sols is due to 2 factors. One of them being that they are charged particles, and secondly, and the more important factor being that they are heavily solvated or extensively solvated, which means that the solvent molecules, that is the molecules of the dispersion medium, they form a protective sheath, a protective layer around the colloidal particles of the lyophilic sol, and this prevents them from aggregating, and that is responsible for the stability of these lyophilic sols. So if we want to coagulate a lyophilic sol, then that can be done by adding the electrolyte ion, which is producing ions which are carrying charge opposite to that carried by the lyophilic sol particles, and also by adding a suitable solvent. Now what is the role of the solvent here? Now, when solvents such as alcohol and acetone are added to hydrophilic salts means where the dispersion medium is water, then what happens is that the water molecules are removed from the surface of the colloidal particles. That is, the colloid gets dehydrated. Dehydration of the dispersed phase particles will take place in presence of these two solvents. And when they get dehydrated, then they will lose the protective sheath, the protective layer of the solvent around themselves. And under these conditions, even if a small amount of electrolyte is added, then that will cause coagulation of a lyophilic sol as well. So how can we prevent the colloidal particles from coagulating? The term used for preventing colloidal particles from coagulating is known as protection of colloids. Now, lyophilic colloids have a unique property of protecting lyophobic colloids. So, when a lyophilic colloid is added to a lyophobic colloidal solution, then the lyophilic particles, they form a layer, a sheath around the lyophobic particles and thus protect them from the electrolytes. Such type of lyophilic colloids which are used for protecting lyophobic salts, that is preventing them from coagulating, they are known as protective colloids. And the power of protection of these lyophilic colloids can be expressed in terms of gold number. So what is gold number? It can be defined as the minimum amount of protective colloid which is required in milligrams to prevent coagulation of 10 milliliters of gold sol by addition of 1 milliliter of 10% NaCl solution. That means if you have taken 10 milliliter of gold sol and you add 1 ml of 10% sodium chloride electrolyte solution into it, then it will cause its coagulation. And if you want to prevent this coagulation, then you are adding some protective colloid in it. So what is that minimum amount of protective colloid required in milligrams to just prevent the coagulation of 10 ml of the gold sol? That is known as the gold number of that protective colloid. So it is very clear that higher is the gold number, the lesser will be the protective power of the lyophilic colloid. Whereas smaller is the gold number, the higher will be the protective power of the lyophilic colloid.